All right, so last class we were talking about quadratic equations, right? Yes? Okay, so remember that a quadratic equation is any equation that looks like this. All right? So we're looking for the equal sign, we're looking for our variable squared. At the end of class, I actually derived a formula that we can use to solve any quadratic equation, and that's what's called the quadratic formula, right? So I'm going to state that now explicitly. The solutions to this I'll say to any quadratic equation. So you might have one solution, you could also have two solutions, you could have no solutions. We'll see that in a second. So I'm going to put a slash here. The solution or solutions to any quadratic equation are, okay, so here's the formula, the quadratic formula. X, that's your answer, is negative b plus or minus the square root of b squared minus 4 times a times c, the entire quantity divided by 2 times a. And that is the quadratic formula. So I showed you all where that came from, right? Last class at the end, showed you where this actually came from. We don't need to know that, where it came from. We just need to know what it is and how to use it, all right? So all you have to do to use this formula is identify what A, B, and C are. So you have to know what the number here is, the number here, and the number here. And once you know that, you just plug it in and you figure out what the answer is. All right? So we're going to do a couple of problems. We're going to practice it. And then at the end of class, you're going to take a quiz. And I'm going to let you all work together on it. And I'm just going to give you a couple of quadratic equations and make sure that you can do the mechanics behind this. All right? All right, so let's do a couple of these together first. All right, let's start with an easy one. Let's solve x squared minus 2x minus, what do I want to do here? 15 equals 0. All right, so first thing, you have to look at it. You have to recognize that it's a quadratic equation, right? It is? Yes? Okay. So once you do that, you make sure it looks like ax squared plus bx plus c equals 0. So in other words, make sure that everything is over on one side and you have 0 on the other side before you start. All right, so we have that, right? Everything's to one side. The next problem I give you, I'm going to scramble things up and it won't look exactly like this, so we'll have to, as a first step, move everything over. Okay, so everything's moved over. So what we're going to want to do now is just identify what A is, what B is, and what C is. So what is A? 1. It's the number in front of x squared, right? Which is this number, which is 1. B is negative 2, so make sure you pick up that sign. It's negative 2. And C is this number, so negative 15. Once you have the three numbers identified, we just go right into the formula. Okay? So we will need our calculators for this today. So if you have your calculator, make sure you have it handy. All right, so here we go. I'm going to plug into this formula. So one of the most common mistakes I see is this one right here, this number right here. That is saying that in the formula, you want to put negative b, which really just means the opposite of whatever you have as b. Okay, so what do we have as b? We have negative 2. So we want to take the negative of negative 2, which would be positive 2, right? So it's always, that first piece in green is always just going to flip the sign of whatever this is. This is negative, it'll be positive. If this was positive, it would be negative. So here we're going to put what? Positive 2 plus or minus square root. Now this plus or minus means that we're actually going to get two answers. And with quadratic equations, we normally have two. Sometimes we only have one, sometimes we have none. We'll talk about that later. For now, just keep in mind that this means we have to look at 2 plus this and then 2 minus this. We have to look at both scenarios. Okay, the next important part is this b squared. Now let me just ask you, every time you do this quadratic formula and you put b squared here, is it going to be positive or negative? This number? Positive, always, no matter what, because you're squaring a number, right? So if it starts out negative, you square it's positive. If it starts out positive, you're going to square it's still positive. So no matter what, this left corner of this square root is going to be a positive number. Now for us, what is it? It's this number, right? Squared. What's negative 2 times negative 2? Positive 4, right? That okay? And then minus, okay, so minus 4, and this is multiplication and multiplication. So 4 times a, what's a? 1, right? So I'm going to put it in parentheses, 4 times 1. And then times c, for us c is negative 15. I put that in parentheses. Then you have division, right? That division bar goes all the way across, okay? It is not just underneath this. That's another mistake I see. This division bar has to go all the way. It's underneath the 2 also. And then on the bottom we have 2 times a, and a is 1. Okay, let me silence my phone. I apologize. Okay. All right, so far okay? So the idea here is this. If you have a quadratic equation, you're provided a nice formula for it. And then we should get the answers without any sort of thinking, I guess. It's just, we call this plug and chug. You're just plugging in things and chugging out the answer. The important thing is, though, you can't mess this up. Like, if you mess this up, like, the answer's wrong, okay? Because you have the formula. You just have to make sure you do the arithmetic right. So make sure you plug everything in right. And now the next critical step is inside this square root, we have to use order of operations. So remember, order of operations says you do this thing. Remember that? Remember multiplication, division, and addition and subtraction went together. So when we look at this, we have subtraction, right? We have multiplication and multiplication. So we're going to do this multiplication before we do that subtraction, right? And this is probably, this step right here is probably the step that's messed up the most by students, this one right here. It's trying to figure out what these numbers are together. So I can give you a quick little kind of shortcut for this, all right? Right now, when you look at this, how many negative signs do you see in here? 2, right? If you see 2 negative signs, the result of these numbers together should be a positive. Okay, so if I see negative and negative, I'm going to get a positive answer. If I see negative, let's say this was negative and that's negative, then I'd have 3 negative signs, right? If you see 3 negative signs, then it's going to be minus. So it's basically an even number of negatives, you get plus, an odd number of negatives, you get minus. With me? Okay, so once I know that I'm going to get a what here? Sorry, a what? Plus or minus here? What am I going to get? We have minus and minus, so we have 2, that's even, so I'm going to get a plus, right? What I'm going to write is 4 plus, and now what I need to do is look at these numbers, 4, 1, and I'm not even going to consider the minus sign here, because I've already considered that, and that's why this is a plus. I just want to do 4 times 1 times 15. 60, right? So that's plus 60. Does that make sense? All right, then all of this, the whole thing divided by 2 times 1, which is 2. Okay, let's continue to work underneath that square root. 4 plus 60, 64, right? So we have equals 2 plus or minus the square root of 64 all over 2. Another mistake I see right now is students try and divide, like, oh, they go 64 divided by 2. You cannot touch this yet. You have to figure out what this is first, then you'll divide by 2 at the last step. Now the square root of 64, we actually could use our calculator, but do we know what the square root of 64 is? It's 8, right? It's a perfect square, right? So that's 8. So my next line is going to read 2 plus or minus 8 over 2. So the square root symbol goes away when I actually figure out what that is, right? Square root of 64 is 8, no more square root symbol. Now at this step, what I like to do is I like to take this and look at both of the two scenarios, the plus and the minus. So here I'm going to be looking at the plus and here the minus. So if I look at the plus, this is 2 plus 8 over 2. And if I look at the minus, I get 2 minus 8 over 2. Understand? I'm just kind of like splitting it up now. And what's 2 plus 8? 10, right? So this is 10 over 2. And finally, at this step, I divide by 2 and I get 5. And then over here, I do 2 minus 8, which is negative 6, divided by 2, and that's going to give me negative 3. And these are my two solutions. Questions? There's a lot of things you have to keep track of, but at the end of the day, it's just arithmetic, right? So saying that the answers to this are 5 and negative 3 means that if I plug 5 in for x here and here, this thing should be true. And if I plug in negative 3 here and here, this thing should also be true. Like we should get 0 on both sides. Okay, now I want to show you something with this problem. That took a little while, right? I mean, we went through it kind of slow, but what if I come back up here to this problem from the very beginning, and instead of using the quadratic formula, I realize I can factor this using the AC method. So remember we did a whole day of factoring at least, 2 days of factoring? If I look at that, that's 3 terms, right? There's no GCF. And if you're comfortable with factoring, you could figure out, maybe it would take you a few minutes, but you could figure out that that left side turns into x plus 5, x minus 3 equals 0. Okay, so if you're comfortable with, minus and plus here. Okay, so that's what it would be with the AC method. And then we talked about this. This was called the zero factor property. If two things multiply to be 0, you set them each equal to 0, right? So if I set this first one to 0 and set the second one to 0 and add 5 to both sides, I'm going to get the same two answers, right? Okay, so this is going to depend on you. On a test, when I say solve a quadratic equation, if you can factor and you're comfortable with that, do it, right? It might be faster. But if all else fails and you try the AC method and you can't figure out what's going on here on this table, then you can always fall back to the quadratic formula. It's always there for you. Understand? So I leave it up to you to figure out which way is the most efficient way for yourself. Okay, let's do another one. We got some nice answers there, didn't we? 5 and negative 3. Nice little integer answers. So let's do this one. Let's go 3x squared equals 5x minus 11. All right, is this a quadratic equation? Is it an equation? Okay, is it quadratic? X squared, you have an x squared in there? It is quadratic, right? So it's a quadratic equation. We know we can use a quadratic formula. We might be able to factor. Let's first do what? Move everything to one side, okay? We want 0 on one side, all the terms to the other side. So what I'm going to do is I'm going to leave the 3x squared here. I'm going to move this one over and this one over. And what happens when I move those over? Like when that goes over there and that goes over there, to change the sign. So this is going to become minus 5x over there and plus 11. So we've got 3x squared minus 5x plus 11 equals 0. Now when you go to use this formula, or when you're looking at this, notice that this is in what's called descending order. You have like the x squared is first, then you have the x1, right? Then you have the number, then you have equals 0. Make sure you put it in the right order over here. And now at this point, it's up to you. Factor or quadratic formula? What do you think? I don't think we're going to be able to factor this. I don't think it's going to go. If we try the AC method, and you know what? I'm not ready for this problem. Hold on. Let's change one thing because I want this to work. I want this to actually work out. Can we all change this to a plus? Change that to a plus right there, everyone. How does that change this line? This is going to be a negative 11. Okay. I want us to get an answer on this one. Okay. Sorry about that. Still is not going to factor. Okay, so you can try your little AC thing. You're not going to be able to come up with two numbers. But we're not going to say prime anymore. We're just going to use a quadratic formula. All right? So I erased it. I'll put it over here for us. On your exam, I will provide you the formula. All right? You don't have to memorize this. All right? I'll give that to you. All right, so what would be our next step, Evan? Oh wait, Evan, I think I called you last time, didn't I? All right, we'll start over here. Rodrigo. I think I called on everyone, so we're all playing today. Rodrigo, what's the first thing I should do here if we're going to use a quadratic formula? Yeah, just figure out A, B, and C. Just list them out. So Rodrigo, what's A, what's B, what's C? A is 3, B is negative 5, and C negative 11. Everyone agree? Okay, now we go to the formula. X is equal to, all right, Rodrigo, go ahead. What do we got? 5, okay, plus or minus square root. Okay, what's that piece right there, Rodrigo? 25, right? So that piece is always going to be positive, 25. Okay, you're off the hook. Let's see. Kayleen? There you are. All right, pick up where Rodrigo left off. We had 25 minus, now what should I put here?
Minus 4.
4.
And then parentheses 3,
And then negative 11? Is that what I heard? Okay, in there. And then division. Stop right there.
No, you keep on going.
Keep going, right? Okay.
And then you do 2 in parentheses 3.
Okay, good. Everyone good? All right. Kayleen, when I put these numbers together, am I going to get a plus or a minus when I do that?
A plus.
A plus, because we have negative and negative, okay? So next line, what I suggest you write is the 25 and then a plus, okay? Because you know it's going to be a plus. And then just multiply those numbers together. You're just going to take 4, you're going to take 3, and you're going to take 11. Again, you're not going to care about the sign. You ready? Took care of the sign. What is that? 132? Okay, 132. All of this divided by 6. Okay. Yeah. Okay, so 5 plus or minus square root. The next step is just to add these two numbers together. So what's that going to give us? 157 over 6. All right, so we are at a step where we were last time, where we had a square root. We had square root of 64, didn't we? And we were like, okay, square root of 64 is 8. This time, square root of 157 is not something that most people are going, well, I don't even know what square root of 157 is because it's not a perfect square, right? So this is where we need our calculator. So everyone needs to find the square root key on their calculator, which is, there's a key on your calculator that says x squared. And then right above it in green, there's a little, there's a little green square root of x, or no, it just says square root above it, right? So what you have to do to use that key is you have to hit the green key in the top left corner first. That will activate all the green keys. So You hit that, then you hit the x squared key, and it should show you in your little calculator just a square root, and then inside it should just be flashing. Okay, now we're just going to type in 157, and then we're going to hit enter. And what does it tell you? Tell you what mine tells me. Yeah, so you type in 157 here in your calculator, and you hit enter, and it spits out square root of 157. So it didn't do anything, did it? And the reason is because your calculator does not want to, it doesn't want to give you a decimal answer. It wants to give you the exact answer, which is this. So the way we're going to change this, I want you to start over. The easiest way to change this is to bring up the square root again, but instead of typing in 157, I want you to type in 157.0. And what that does is it tells your calculator, look, I'm okay with decimals now, all right? Square root 157.0, and now what does it give you? Okay, 12.5299 something 6409, something like that, right? Now, if you're using a calculator other than this one, you might have got 12.59 right off the bat. Okay, it just depends on your calculator, but I'm going off of this one. So we have all these decimals. In this class, I only want us to round to like the first two, all right? So we're just going to round, we're just going to say like 12.53. Is that okay? And this is an approximate answer. So the square root of 157 is approximately 12.53. So my next line should read this. X equals 5 plus or minus, do I do the square root or no? No, because we took the square root, right? So whatever's left here is just that number, 12.53, rounded, and then over 6. Once you get past the square root part, this is where you split it off into the two answers. So from here, I'm going to take the plus and then the minus. Is this making sense what I'm doing here? Are there any questions? So I'll do up here 5 plus 12.53 divide by 6, and then here I'll do 5 minus 12.53 divide by 6. Okay, so we have to do this. What's up in that numerator first? Right? So you should be getting 17.53 and then divide that by 6. Getting about 2.92. And then you do this one, right? You should be getting negative 7.53 on top and divide that by 6. And you should be getting about negative 1.26. I'm rounding that. It was really 255, but I rounded that second decimal up to 6. I'm not going to be real particular about this. I want this digit to be accurate, this one not so much. So that's why I want you to round on this one, because if you mess that up, we still at least have this digit right. All right, good? So that means that if you plug that number, 2.92, into the original equation, it should be correct. And if you plug in negative 1.26, it should be correct. So we have answers, even though we couldn't factor it. Remember in the beginning we said maybe we can factor? If you tried factoring, you would just be stuck. The quadratic formula guarantees that we are going to get our answers. All right? Let's do another one. We're going to do at least 2 more. Okay, let me think for a second here. X squared plus 4 equals 4x. All right, Kristen, is this a quadratic equation?
Yes.
Okay, so what should our first step be?
Move the 4x over so it becomes x squared minus 4x plus 4 is 0.
Okay, and you already put it in the correct order, right? So you move that over, it became negative, you realize that it was going to need to go in the middle, right? So if you don't do that correctly, if you mess up the order, then your A, B, and C could be wrong if you don't pay attention. So, all right, keep going. You have A, B, and C here. Or yeah, even though this does factor, I want us to do the quadratic formula, just to see what happens.
A would be 1.
1,
B would be
negative 4, C is positive 4. Okay, I erased the damn quadratic formula. Well, you've memorized it by now, right?
So it would be
Yeah.
negative,
Okay, you want me to?
negative 4, which is positive 4.
Positive 4,
Plus or minus negative 4 squared,
which would be
16.
16 minus 4
Minus 4 times 1
times 4, all over
over 2 times 1.
2 times 1, okay? So do I need to write the formula down, or everyone has it by this point, right? Okay. Kristen, are we going to get a minus or a plus after that 16?
Minus.
A minus. And it's because you only see one minus sign here, right? And if it's an odd number, it's going to be a minus. So my next line should be 4 plus or minus the square root. I'm going to write 16, and it's a minus for sure. And now I just multiply these numbers, not caring about their signs. Just multiply those together, which gives you 16. That's weird. Okay, 16 minus 16 over 2 times 1 is 2. So this is 0, right? What's the square root of 0? 0, right? So what we're getting here is this: 4 plus or minus nothing over 2. Well, what's 4 plus nothing? 4. What's 4 minus nothing? 4. So if I go and do both cases, it's the same thing, isn't it? So this is really just 4 over 2, which is 2. We only have one answer, right? In the previous two problems we did, we had 2 answers. Here we're only getting one answer. And that is possible. With quadratic equations, you could get 2 answers, 1 answer, or no answers. Those are the possibilities. You can never get 3 answers with a quadratic. Okay, so if that's a 2 up there, you're guaranteed to have either 2 answers, 1 answer, or no answers. In this case, we got just 1. Now, let's go back to this point right here, Kristen. I said it could factor, right? So if you do the AC method here, you would actually figure out that this is x minus 2 times x minus 2. And you see these are the same, aren't they? And so if you set these equal to 0, you get 2 for both of them. So you get still just one answer. We call it a repeated root, but that's not important, all right? It's 2 answers, but they're the same answer, so it's really one answer. Okay, questions on that? The key indicator that you're going to get one answer is any time that thing right there is 0. If this thing inside here is something other than 0, you have 2 answers. Because then you'll have plus or minus something here, right? But if that's 0, then you're only going to have one result. All right, last example before we talk about something else. Let's do this one. Negative 5x squared plus x equals I want to make sure it works out the way I want it to work. 7. There we go. Macy? What first? Okay, so you're wanting to get A, B, and C? Okay, What about the 7? Yeah, okay. So move it over first, right? Okay. So we're going to move it all over. Macy's doing this because she knows right away that it's a quadratic equation. So she knows that that means she's going to need to move everything over and get A, B, and C. Macy, would you try and factor that like on a test? You just go straight to the quadratic formula because you just believe in that and that's like...
Well, if you try to do the AC method, you're not going to get anything.
Okay, so you just look at that already and you know that AC method, you're not going to get anywhere. Okay, so but I'm asking you, would you, like on a test, would you be doing AC method first, do you think?
Yeah.
Yeah, okay. So like I said, it's up to you. But if you recognize right away AC method's not going to work, then go to your quadratic formula. The quadratic formula will never let you down. It'll always work as long as you plug in your numbers properly. All right, so Macy, A, -5, 1, -7. All right. You want to keep going? Okay, this is the first time we've actually had this happen for B. So what's our top left corner? -1, right? I think every example I've given us so far, B has been negative, so when we put it into the formula, it's been positive. This is the first time that B was positive, so when we put it in the formula, it's negative. Okay, plus or minus, square root. Okay, B squared, 1. Minus 4, and then times -5 times -7 all over 2 times -5. All right, good. Any questions? Macy, are we going to have a plus or a minus behind this 1? Is this going to be 1 minus or 1 plus? 1 minus, because there's how many negatives? 3 negatives. An odd number of negatives means you're going to have a negative sign. So I'm going to do -1 plus or minus square root 1, you said minus, and now we take these numbers, 4, 5, and 7. Ignoring the signs, right? Just multiply them together. What's that? 140. All over -10. All right, we're getting there. Okay, -1 plus or minus square root. Now you just put these together, right? So Macy, what's 1 take away 140? -139. All over -10. Now 139 is not a perfect square, so maybe we need to use our calculators for this. What's the square root on your calculator, the square root, and then we have to put negative, right? There's a negative key and there's a minus key on your calculator. They're two different things. Your negative key looks like this. It's below the 3. The minus key is by itself in gray on the right-hand side. If we want to do the square root of -139, you're going to use this key. So -139, and then you hit enter, and what happens? Domain error. What? These things are cheap, right? We should have bought the more expensive one. What's going on? Why is it giving us a domain error? You can't take the square root of a negative number. So where did you learn that? Somewhere in the past? So let's take a quick pause from this and talk about square roots real quick. If you say the square root of 4, the answer is what? 2. Why is it 2? Well, it's 2 because what we're saying is 2 squared gives you 4, right? If I say what's the square root of 9, the answer is 3. Why? Because when I square that 3, I get 9. If I take -4 and try and come up with an answer, right? If we could find an answer, then what we'd be saying is that answer, whatever it is, squared has to be what? Whatever, like here, right? Whatever the answer is, when I square it, I get the 9. I get this. Here, whatever the answer is, when I square it, I get this. What's under here? So if this has an answer, when I square it, what should it come out to be? What's under here, right? -4. What's wrong with that? What's wrong with this idea? No matter what this number is, right? When you take a number and square it, it always turns out to be positive, right? This is not possible. It is not possible to square a number and get -4. So when we have negatives under square roots, there's no solution to this. This doesn't make any sense. So what does that mean for us over here? As soon as we get to this point, what is this telling us? We can't calculate that, right? Which means there is no solutions. Okay? This right here, right now, we know that there is no solution to this quadratic equation. And we're done. So the original problem, which I've erased, it was what, -5x squared, what was it? Plus x equals 7, right? That was the original one. What we're saying is that there is no x that you can ever plug in. There's no number that you can ever plug in to make this true. Doesn't happen. And I told you we could have 2 solutions, we could have 1 solution, we could have no solutions. This is an example of no solutions. With me? Sure? Now I know some of you have seen, what?
Oh, it's just kind of a, I guess, jumping the gun, but like if we went and graphed this, so there wouldn't be anything crossing.
Yeah, so we're going to start that next class. We're going to realize that all quadratics look like parabolas. And so this case would be a case where, well, it opens down because there's a negative, but I don't want to get too technical. This would be a parabola that looks like this that never hits the x-axis. That would be this scenario because it doesn't hit the x-axis, there's no solution. The one we did before this had 1 solution, right? That one would be a parabola that looked like this. It hits just at that lowest point. And then the ones that we did when we got 2 answers would be parabolas that hit more than once. But yeah, we're getting a little ahead. Yeah, but that's exactly what it is. It corresponds to this scenario right here. Now, nobody mentioned I. No? Have you all heard of I? The imaginary number? Yes? So like some of y'all might have been saying to yourself, well, isn't this like 2i or something like that? Or you were taught that the square root of -1 is I. Okay, maybe you've seen that. We're not going to discuss this at all. At all. Okay? We're just going to act like this doesn't exist. And we're going to have no solution. And there's a reason why, okay? There's a reason why we're not going to talk about it. It's not worth our time. Because this topic right here, this topic is such a huge topic in mathematics that we couldn't give it any justice in this class at all. Like, it would just be like me opening the window and letting you peek for a second and closing it and never letting you look again. You would just get a glimpse of it, that's it. So, to me, it's not worth it. But I will say this about it, okay? I will only say this. And I'm going to try really hard to keep myself on track here. Have I given you the fishbowl analogy yet? Okay, so when you have a fishbowl sitting on on a table, right? Here's the fish. I know. If you're jealous of my artistic abilities, I understand. So these are fish, right? Do you think that these fish have any idea that you have a dog in the backyard? Yeah? Yes? What kind of fish? Who said that? Is that you? What kind of fish do you have? Right? So do these fish in the fishbowl have any idea that there's a whale in an ocean somewhere? Or a goat up on a mountain somewhere? You know what I'm saying? Like their universe is right here, right? Like that's their universe. Yes? Okay. So everything that you do in math, everything that I'm sure everyone in here, everything you'll ever do in math in your whole life is dealing with these things called real numbers. Have y'all seen that before? You may have used that in the past to represent like all real numbers. So it's basically representing all the numbers on a number line. Every number you could think of. 1, 2, -5. If you've heard of pi or square root of 2. Any number you could ever think of. These are all real numbers. Okay? That's all you ever deal with. I'm just telling you that you live in a fishbowl and all you ever see, your universe is R. Okay? That's all you'll ever know. But I guarantee you that there is an entire universe outside of this that have numbers that we work with, that we use, that are just as real as the whale in the ocean and the goat up on the mountain. And those numbers outside here make up what are called the complex numbers. Okay? And those complex numbers belong to this universe, all right? And inside this complex numbers is that number I. Okay, it's in there. So we are going to stay in the fishbowl. We're not going to look outside the fishbowl, and that's where we're staying, all right? Okay? All right. Imaginary numbers get a bad rap because the first mathematician who ever came up with them, other mathematicians didn't believe that they were worthwhile. Like they thought it was all just like hocus pocus magic. And so they called them imaginary numbers because it was like someone's just making it up. And then later on, it was proven that they are just as valuable as the numbers that we use right now, like 4 and 5. So, but it's stuck with it like forever. It's always going to be imaginary numbers. No. Okay, so we have seen several examples of solving quadratics with the quadratic formula, right? We've seen where we get 2 answers. We've seen where the quadratic formula works, but also factoring could have worked. We've seen where we use quadratic formula and we get 1 answer. We've seen the quadratic formula where we get no answers. All right? So now what we're going to do is switch gears a little bit, and we're going to look at some special cases. Okay, your first special case, you're missing the constant. So what do I mean by that? What I mean is this. Let's say you have a quadratic that looks like this. ax squared plus bx equals 0. So what's missing here? You don't have a c, right? C is not there. Now you could say c is 0 if you wanted to. You could say that yes, there's a constant, but it's just 0, so it's not really here. Do y'all see the difference between this and ax squared plus bx plus c equals 0, right? If we ever have this scenario, yes, you could use the quadratic formula. You could. What would c be in the quadratic formula? C would be 0, but you'd be wasting your time because there's a much faster way to get to your answers if you have this case. Let me show you. So here's a specific example of this special case. Is that a quadratic equation? Equation, quadratic, right? Okay. Are you missing the constant? Yes, you're missing the constant, right? You just have the x squared term and you have the x term. Instead of using the quadratic formula, all you have to do here is GCF, greatest common factor, on the left-hand side. So look at the left-hand side. What's in both of those? X. So you just factor an x out, and then you'll be left with 3x minus 4 equals 0, right? And now you have 2 things that multiply to be 0, right? And whenever we have that, we just set them both equal to 0. So I'm going to set this one equal to 0. I'm going to set the other one equal to 0. And now I have 2 little equations I go solve. Isn't that pretty straightforward? Like if you're missing that number, then you'll always have x in both of these, won't you? And so you'll always be able to pull that x out. And then you'll just be able to set those 2 things equal to 0 and be done. What's this one? This one's already solved. That's just 0. X is 0 is one answer. This one we'd have to move the 4 over, divide by 3. That's a little linear equation, so I'm trusting that you can all solve that, right? And we're done. See, this is much more efficient than having to go through the whole quadratic formula. Don't you agree? I mean, could you have used it? Yes. But not really advisable. Let's do another one. How about this? Is that a quadratic equation? Is it an equation? Is it quadratic? Okay. So our first step is to move everything to one side, right? Move everything to one side. So I'm going to move the 81x to the other side. Now, when you look at that, you just don't want to be like pulling out the quadratic formula every time you see a quadratic. Okay? You want to like think a little bit about it. This is quadratic, but it's missing the constant term, right? So since missing constant, we'll just factor out whatever we can, GCF, and then just set those two things equal to 0. So, Victoria? Which would be? You can take an x out?
Actually, we can do numbers. So
A 9 too also, okay. So you can pull a 9 out and an x. Agreed? And then what would you be left with here? X minus 9. And then still equals 0, right? And now what are the two equations that I'm going to set up here? 9x equals 0, and the other one? X minus 9 equals 0. Okay? Now on this one, what do we do to solve for x here? Just divide both sides by 9. And when you divide this side by 9, you get x. And when you take 0 and divide it by 9, you still get 0. So this is just 0. And then over here, you just add 9 to both sides. So we get our two solutions. Right? 0, 9. So of this, I said there's special cases, right? This was case 1. Case 1, pretty clean, yeah, okay. Let's look at case 2. Does anyone have a guess as to what case 2 is? If case 1 was we're missing the constant, anyone know what case 2 would be? Missing what? Yeah, missing the bx term. So what would that look like? ax squared plus c equals 0. So it's like you have a squared term, you have a number by itself, but you don't have that x term in the middle. Let's see how we would handle this. So let me give you a specific example. Let's go with 4x squared minus 9 equals 0. This is a quadratic, right? Quadratic equation, missing the bx term. Does everyone see that we're missing the bx? We have the x squared term, we have the constant, we just don't have that x term in the middle. Okay, so the way to go about this is very different than anything we've done in terms of solving equations today. What we're going to do is kind of like a linear equation. We're going to try and isolate that by itself on one side of the equation. So if I want to get x squared by itself, first thing I'll do is add 9 to both sides. And then, what do you think?
Square root.
Not yet. I'm going to do one more step before I do the square root. Divide by 4 on both sides. See, and what we've been able to do is get the x squared by itself, right? Now our goal is to figure out what x is, not what x squared is. So to get x by itself here, I need to kill off the squared. So to kill off the squared, I take the square root on both sides. So my next line would be this. My next line would read, the square root of x squared equals the square root of 4 over 9. 9 over 4, thank you. I'm missing something here. Plus or minus. Okay, so anytime you take the square root on both sides of an equation, like we just did, you must always include both the positive and the negative answer. The idea is this. What if I told you x squared was 4? Right? And you came in and took the square root on both sides. this side would become x, and this side would be 2. So you're telling me that 2 is the answer. 2 squared is 4. I agree. But negative 2 would have also worked, right? Negative 2 squared. So the only way to account for both of those is to have made this a plus or minus, which gives us 2 answers here. So you have to remember that, plus or minus. In this class, if you're taking a test and you forget the plus or minus, I'm going to dock you a couple of points. If you're in my 1414 class, these are engineers, people who want to go on to build bridges and airplanes, you miss plus or minus and I don't give you any credit for the problem, right? Because I want to fly in a plane and not worry about the wings falling off, right? So here, plus or minus you forget a couple of points. But I can't give you full credit if you don't do plus or minus, all right? Okay, left side of this is x. Right side of this is plus or minus. Now when we do the square root of a fraction, you can do the square root on the top and bottom separately. So what's the square root of 9? 3, and then what's the square root of 4? 2. So you have 2 answers. Positive 3 halves and negative 3 halves. Those are your 2 results. All right, so anytime we see this, we're going to isolate. The whole idea is to isolate this, and then you'll do square root, you'll do plus or minus, and you should have your 2 answers. Quick question here. What if I started the problem again, gave you this, and made that a plus instead of a minus? It's still that special case, right? So you'd move the 9 over. It'd become 4x squared equals negative 9. Divide both sides by 4. And then at this point, you would take the square root. But what's wrong with that? You're going to have a square root of a negative, right? You live in a fishbowl, so you can't do that, right? So what would we say? No solution. All right? So we have no solution there. All right, so that's special case 2. Special case 1 was we're missing the c.